Hello class, this is Mr. Ezra. In the last two videos, we talked about how to handle situations where you were solving a quadratic and you had the difference of two squares or the sum of two squares. And those are situations where you're going to end up looking at it and saying, oh, there's only two terms to the left side of the equal sign, so I can't factor the way that I do when I have three terms. So there's kind of like, if there's three terms, you're going to try to factor it, right? If there's two terms, you're going to try to look at, well, can I use the difference of two squares or the sum of two squares? And what I'm going to talk about today is what to do when there are four terms, four parts on the left side of the equal sign that you are trying to solve. So this method is called factoring by grouping, and you'll find out in just a minute why we call it factoring by grouping, because we're going to do some factoring and we're going to do some grouping. Basically it. Okay, so here are the steps at the top here. First, we're going to group the first two and last two parts together. So once these are in a good order, we're going to try grouping the first part together. So I'm going to put parentheses around that. And we're going to try grouping the second part together, and always put the negative here on the inside of this grouping. So when we think about this grouping, we want this negative to be a part of this grouping, okay? Now we are going to find the greatest common factor of both groups. We've talked about greatest common factors before, bringing it back here. When I talk about the first group, I'm just talking about the person, these two terms on the left here, x to the third minus 2x squared. The common factor there is not a number, it's not a coefficient, because you've got a 1 and a 2 and there's nothing bigger than 1 that we can factor out, but the common factor here is a variable. Remember, when you factor out a variable, if I have x to the third and x to the second, I'm going to factor out the smaller of the two. It will always work out to you can factor out the smaller two. So since there's an x in both parts, I factor out the smaller x, which is 2x squared. Now, you have to be good with division here. X to the third divided by x squared. Maybe we can come down here and think about this. Remember the subtraction rule. If you have more on top than bottom, you subtract 3 minus 2, and that gives us x to the first power, just x. So what's going to be left behind after we factor x squared out is an x. Well, for 2x squared divided by x squared, the x squareds are actually going to cancel each other out, aren't they? Leaving us with just 2. So minus 2x squared, the x squareds, when we divide that out, cancels out, and it's just minus 2. That's what's left behind now. Let me erase all this stuff down here. We're not going to need it. All right. On the left side, on the right side, we're going to do the same thing. We're going to take a greatest common factor on the right group. Quick note, whatever sign is in front of this first term in the second group, or the third term overall, that is the sign that you want to factor out. So we're going to not just factor out the greatest common factor, but a negative greatest common factor. So when you look at 9 and 18, since 9 divides evenly into 18, we're going to divide out the 9. That's the greatest common factor. And what's going to be left behind when we do that, if you need to come off to the side to do this, you can. Right? We're dividing by negative 9, so what's left behind is x. And on the right one, we've got 18 divided by negative 9. We're factoring out the negative 9, so we're dividing out a negative 9. That leaves us with negative 2, which is x minus 2. Okay. Again, we'll erase this stuff, this extra stuff down here, this division. Some of you are going to be able to do this in your head, right? You're going to say, oh, divide by 9, that's x. Divide that by negative 9, that's negative 2, and that's fine. Now, what you should notice at this point is that what's inside the parentheses should be exactly the same. If it's not the same, either you've made a mistake or it's just not going to work. And it's possible that you get four terms and you try to use this grouping method to factor them, and it just doesn't work. So that's a possibility. Okay. Now, if the parentheses are the same, we're actually going to factor out the parentheses. So when I factored out the x squared, I moved it to the front. When I factored out the negative 9, I moved it to the front of that group. Well, I'm going to take this x minus 2, which is a part of the first and second part here, right? X minus 2 is here, x minus 2, and I'm going to factor it out to the front as x minus 2. And what's going to go what's going to be left behind? Well, if I divide this part by x minus 2, an x squared is left behind. And if I divide this part by x minus 2, a minus 9 is left behind. So essentially, if you think about it, the part inside the parentheses is going to be first in its own little parentheses. We're factoring it out. And the leftover bits go in another parentheses. So x squared minus 9. Now, look at this carefully. Can you factor further? Well, we just talked about the difference of two squares, didn't we? We got an x squared, which is a perfect square, and a 9, which is a perfect square. So we can factor this further. So let's put some equal signs here since we're kind of following this progression. The x minus 2 is as small as it's going to get. It's factored as far as it's going to go, so bring it down. But x squared minus 9 is the difference of two squares. And we remember that when you have the difference of two square, dots, you take the square root of the first part, x times x is x squared. The square root of the second part, 3 times 3 is 9. And you get two signs, a minus sign and a plus sign. Now, since we are factoring here and not solving, there's no equals 0, so we're not solving, we're looking for factors. That is as far as we can go. This is as good as it's going to get on this question. All right. For number 20, we're going to do the same thing, follow the same progression of steps. We'll start by grouping the first two terms together, the second two terms together. We are then going to look for a common factor in the first part. Now, in this, the common factor in the first part is 2 goes into 2 and 8. And x squared is part of both of those. And when I divide, the 2 divided by 2 is gone. They cancel out. X to the third divided by x squared is x. The negative 8x squared divided by 2x squared, well, let's think negative 8 divided by 2 is minus 4, and x squared divided by x squared cancels out. Now again, you can come down to the bottom and do that, like 2x to the third over 2x squared, and solve it, and do this part over 2x squared to find what's left behind if you need to. I'm just going to do it right here. All right. That is the left grouping. The right grouping, 3 goes into 3 and 12. So I'm going to take out a 3. Now remember, this sign is always what comes out with it. So it's a plus 3. 3x divided by 3. The 3's cancel out, leaving an x. Negative 12 divided by a positive 3 is negative 4. So now that we've done this, we want to check, is what's in our parentheses, is it the same? If it's not the same, we want to go back and try again, think about it again, maybe we made a mistake. If we try it again and we still get the same thing, maybe it's non-factorable. Most of the questions I give you that have 4 terms are going to be factorable, I would imagine. All right, so this x minus 4, it gets its own parentheses. So it's going to go out to the front as x minus 4. And the second parentheses is going to be the leftover bits, right? That when we divide both of these parts by x minus 4, what's going to be left over is 2x squared plus 3. All right, now we want to ask ourselves, can I factor out the 2x squared plus 3 further? Well, there's 2 terms, but it's not a difference of 2 squares. And when you have 2 terms that are not a difference of 2 squares, you cannot factor them further. So this is actually our factored form. This is as far as we can go, as far as we can factor. X minus 4, 2x squared plus 3. All right, let's look at question 21. And as a reminder, you can always pause the video, try the problem, see if you can do it on your own. You know, you've seen a few examples now, and then start the video up and see if you get the right thing. Often, if I were teaching this in class, I'd say, okay, you guys try the next one, and I'll let you try it for a few minutes. So that's a good thing to do. If you're still a little fuzzy, you'll get plenty of practice on this, so you can just take notes on it. It's up to you. Our first step, group the first part, group the second part. In the first part, we look for a common factor, greatest common factor. 4 goes into 4 and 16, so that's the greatest common factor of the number part. Of the variable parts, you choose the smaller one, x squared. Okay, now 4 divided by 4 cancels out. X to the third divided by x squared leaves us an x behind. There's one x that doesn't come out. 16 divided by 4 is positive 4. And x squared divided by x squared cancels out, so we've got 4x squared, parentheses, x plus 4. Okay, now in the second parentheses, we're going to factor out a greatest common factor. Well, I see this negative here, and I've been saying this, and you need to remember this, that always whatever you factor out is going to have a negative. Whatever this sign is, not always a negative, I'm sorry. It's always whatever sign is the third term or the first part of your second grouping. That's your sign here. So we know we have to get a negative something out. Got to be a negative something. And I start looking at 1 and 4, and I say, well, there's not a common factor bigger than 1. And I look at the x's and the x, and there's not 1 in both parts. So really, I can't factor anything out here other than a negative 1. And in factoring by grouping, you have to factor something out. Whether it's a positive 1 or a negative 1, it has to be something. It has to be the greatest common factor. Well, in this case, the greatest common factor between these two terms is the negative because of this sign here and a 1 because there's nothing bigger than 1 that goes into both evenly. And that is okay. Now, when you divide by negative 1, what happens, right? The only thing that happens is the signs change. So this is going to become a positive x and a positive 4. We then look and ask ourselves, did we get the same thing in the parentheses? And we did. They're both x plus 4. So we take that x plus 4 out to the front in its own little parentheses. And the leftover bits, once we divide that x plus 4 to the front, go in the second parentheses, 4x squared minus 1. Now I see a perfect square minus a perfect square. So this is the difference of two squares. We can factor further. The x plus 4 is as good as it's going to get. We can't take that one out any further, but the 4x squared is the difference of two squares. 2x times 2x is 4x squared. 1 times 1 is 1. A lot of people have trouble. They forget 1 is a perfect square, but it is. 1 times 1 is 1. And then the signs, we're going to have a negative sign and a positive sign. That's the pattern that you have to get used to with these problems that have the difference of two squares. Now that we have now that we have 3 terms that each are all the way down as factors as we can get, we circle it, we're good. Okay, we can't go any further with this problem. Our last question is a solve problem. We haven't seen one of those with grouping today, but we're going to see it with this solve problem here. So we have 4 terms on the left and a 0 on the right. I do kind of want to make a little note here and remind you that for any of these factoring methods, generally speaking, you need a 0 on the right. So if we had like x to the third minus x squared minus 4x equals negative 4, well, we'd have to add that 4 over to the left to get 0 on the right. If you're solving, you need a 0 on the right for the most part. There are some strategies that you don't have to do that, but most of the factoring strategies require that. So since this has already got a 0 on the right, we're just going to focus on factoring first. Right? So when I'm factoring on the left side, I see 1, 2, 3, 4 terms. That is my indication that I'm going to use grouping. Group the first 2 and the second 2 together. When I group the first 2 together, the part that factors out is an x squared because it's between the 2x parts to 2x terms, it's the smallest. There's no number part that's going to factor out. Well, x to the third divided by x squared is x. X squared divided by x squared is 1. We got this minus sign here, so we're going to have minus 1. Okay, now remember this sign always gets factored out. A 4 goes into both parts, so we're going to divide out a 4. And what's left behind after we divide by negative 4 is going to be x minus 1. Negative 4x divided by negative 4 is x. 4 divided by negative 4 is negative 1. Well, we're doing well because the part in the parentheses here is exactly the same, and this method doesn't work unless it is exactly the same. So I'm going to pull that out to the front, and the other leftover bits, x squared minus 4, go in the other parentheses. And I've made a slightly small error here. These aren't really equal down because I'm not factoring. It's not this progression of kind of working towards factors. Instead, I should have on the right equal to 0 because I'm going to be solving, and that equal to 0 means that I'm solving. It means that I want to find the solutions. I cannot find solutions if I don't have an equal sign, but I can find solutions if it says to solve, and if I have an equal sign. I must have an equal sign. Okay, so can I factor further? Well, yes, I can. Right? I got x minus 1. That one was good. But the x squared minus 4 is the difference of two squares, so I put 2 parentheses. I got x times x is x squared, 2 times 2 is 4, and then a minus sign and a plus sign. All of that is still equal to 0. Well, remember the zero product property that we've been using for much of the solving by factoring. We take each of these factors once we've got them as small as they'll get, and we set them equal to 0. And that's going to give us all of our what we call roots, or what we sometimes call solutions, or what we sometimes call zeros. And when we talk about graphing, they'll also be called x-intercepts, where it crosses the x-axis. Right, so for x minus 1 equals 0, we get x equals 1. For x minus 2 equals 0, we get positive 2. For x plus 2 equals 0, we subtract that over to get negative 2. So those are all one-step equations where we're just going to add or subtract over. I like for you to come off and put all three of your answers together, 1, 2, and negative 2. Again, I get this question often. The order that you write them in doesn't matter. You don't necessarily have to put them in least to greatest. You just have to have all three solutions or roots there. Well, that's it for today. I hope that helps you learn or kind of clean up how to factor by this grouping method when you have 4 terms. This method is only used when you have 4 terms. At this point, we've talked about how to solve quadratics using the square root method. We've talked about how to solve quadratics by factoring when a equals 1, by factoring when a is greater than 1, when you have 3 terms, right? 3 terms when a is 1, 3 terms when a is greater than 1. We've talked about how to factor when there are 2 terms. That's the difference of 2 squares, and we can solve using the sum of 2 squares. And now today we looked at 4 terms. When there are 4 terms on one side of the equal sign, or when you're factoring with 4 terms, that's when you're going to use this grouping method. From here, we're going to be looking towards getting ready for an exam or a test over this unit 1A. So we'll be practicing kind of bringing all of this together so that we can know when to use what type. But this is it for Unit 1A. I will see you in class.